Okay, so I said the speaker is Mr. Yusuf Areda, is a senior developer, and he had trained a lot of people personally, and me personally, and a lot of other people in Nigeria and across in Canada and every other country you can imagine. He has done a lot of work and he uses tech to solve his personal life. When you see some of his applications, some of his personal application, you see that wow, these are applications to just solve ordinary things that you do in your daily life, and that's why tech can be very intriguing if you are beside this man. So he's available, and I'm awaiting him at the moment. So I hope you can just wait for about a minute for him to be on this space. So I'm coming. Okay. So he notified me right now that um he's installing some update that he'll be with us very soon. So in us waiting for him, I will share the screen of some of his resources so that you can actually check on that before he actually comes to take us on that. So until I so can you all see my screen at the moment?
Yeah, yeah.
Okay, okay. So it's going to be taking us through the topic cloud computing, artificial intelligence, and machine learning in modern medicine. So cloud computing, artificial intelligence, and machine learning in modern medicine. So you had prepared a very good PDF material to for us to like go through the class. So he will be with us in some minutes. He's installing some of it, like I've said before. So break. So it's due to some technical issues. So it's very much available right now. So I would hand over the space to him. So I hope you all enjoyed this full, unique premium session from a very senior developer, like I've said before and introduced. So thank you so much. Mr. Yusuf.
Okay, good afternoon, everyone. I'm so glad to be here, and I'm pretty much excited that I'm I'm privileged to be given the quintessential honor to address this interesting and attractive crowd. Again, I'm so honored to be here, and I hope that the content of the presentation would be adequately used as working tools in our lives endeavor. My name is Yusuf Jimo Aweda. I am a senior software developer, automation and artificial intelligence. I'm the founder of TechVarsity, and I'm also Microsoft certified professional, AWS Cloud certified cloud practitioner, and of course, Google Cloud Platform CCC. Of course, that's a certified course completion. So I'm going to be talking about the cloud computing artificial intelligence technology, and of course, mobile and web application in modern medicine. It's a very, very big topic. It's a very, very huge and wide intellectual adventure, but I'm going to try my best to bring forth the synopsis and the point in a way that'll be quite relieving to the listeners. We must have heard about cloud computing before, and it also comes with okay, Mr. Abdul Wahab, can you please project um, the document, the presentation, or I should project myself? Let me
Yes,
see.
you should get it from your side, please.
Okay. Um, Look at the option. What is share screen? Okay, start screen sharing. Okay, you are sharing your screen. Okay, can you guys see my screen now?
Yes, you can.
Okay, thank you. Okay, thank you. So you must have heard about cloud computing before, and people who have not actually heard about cloud computing, they must have heard about cloud as a word in the ICT terrain. So the best way to put that is when you have an on-demand availability of computer system or resources, especially data storage and computing power without direct active management by the user. What does this mean? This simply means, can you all hear me? I wanted to be sure.
Yes.
Okay, Splendid. Okay. So in a layman language, cloud computer simply means when you have your computer in a virtual environment. Let me break it down pretty simpler. You must have seen a laptop before over time. And this physical laptop would have an operating system. Sometimes it could be Windows operating system, which is very, very prominent in our terrain in this part of West Africa. Okay. The other person, you please pause the microphone. There's a microphone interfering with this discussion, please. So you must have heard about laptop, or you must have seen laptops before. You know how personal computer works. It's a computer device that has a monitor, it has a keyboard, it has a mouse, then it has something called operating system. And Windows operating system is pretty much common in this part of the world. We have Windows 7, Windows 8, Windows 10, Windows 11. Okay, so you have this computer, you can touch it, you can carry it from somewhere to another place, you can actually work on the computer physically. But when you talk about cloud computing, you are not necessarily interfacing with the computer physically. You are you are not necessarily interfacing with the computer physically. Instead, you are operating the computer on the virtual environment, which means you could have a MacBook without necessarily having the MacBook at your physical terrain. You could have another, operating system, let's say Linux, apart from Windows. I know you all know Windows, Windows 8, Windows 10, Windows 11. You could have operating system that could be different from Windows, which could be, a Mac OS, which is being produced by Apple Inc. You could have a Linux OS on it. When all of these operating systems exist on a computer, without you necessarily operating them physically, whereby you operate them on the virtual environment, then of course you're talking about cloud computing, which is when you have your services, your infrastructures, your operating system existing in the cloud. Of course, you will need your physical computer to connect to the computer that is resident in the cloud. For example, I can have a Windows system with 500 gig, with 4 gig RAM, and running on Windows 10. If I want to leverage on the cloud computing, I could register on maybe the top three clouds. I'm on the third slide now. We have top three cloud computing platforms. We have the AWS, which is the Amazon Web Services. We have the Azure, which is the cloud nomenclature for Microsoft Cloud. So they call theirs Azure. And of course, we have the Google Cloud, which is the cloud appellation from Google. And we have the IBM Cloud as well, and some other cloud platforms. Okay, these are the three top cloud platforms in the world. You could decide to transcend your services from physical ambience to the cloud ambience using any of these cloud technologies. So AWS, for example, like every other cloud platform among these three top cloud platforms, they offer the provision for you to set up a system on the cloud. So you can have your physical system running on Windows 10, then you could set up a cloud computer that will run on Linux operating system that might have, let's say, 100 gigabytes of hard drive space. It will have a 4 gig RAM, and it will be running on Linux OS, and to be resident in the cloud. So once you launch your system, all you have to do is to go to your browser, sign into your AWS account, then you provision a computer that will run in the cloud, and you can actually, from your system, you can connect to the cloud, resident computer through the physical system that you have. You could also run on macOS. Okay, some of you guys who may think that you can't afford macOS physically, you can actually get all of these devices in the cloud. Okay, you can provision them in the cloud. So that summarizes the definition of cloud. Cloud gives you the privilege to be able to create availability of computer system or resources, especially data storage, computer power, without directly or actively managing them physically by the user. Okay, so when we talk about how this can impact medicine, we'll be talking about the routine administration of medicine itself, because the cloud helps to make and track appointments, financial management, planning, maintaining patient records, and clinical and non-clinical data can easily be streamlined and updated on the cloud platforms, whether through something called IaaS. IaaS means infrastructure as service. If you go to a typical hospital and you have a device that stores the heartbeat of patients that have registered for a particular ailment in the hospital. So what the physical device does is it actually stores the heartbeat of the patient. If you have a device like that, the role cloud computing has come to play is to eradicate that physical ambience for you to store the data of the patient necessarily. You can actually have that infrastructure as a service in the cloud. You can have it as a service in the cloud, whereby you may not necessarily have the infrastructure resident in your office. So this is the beauty of cloud. That's what we talk about IaaS. Or you can have PaaS, platform as a service. For example, you go to an hospital and you want to have the you want to have a scan done for a pregnant woman. In the contemporary hospital, traditional hospital, we have the scanning machine that the doctor will put on the tummy of the pregnant woman to check the position of the baby. We have a physical device that the doctor interfaces with. Okay, these physical devices, when they are not transformed to existing in the cloud, they will not talk about infrastructure as service. You can also have PaaS, which is the platform as service. That's when you have I've given an example. Let's say you want to run a medical software on a Linux operating system. Maybe the developer of the software has written that this software will not run on Windows, it will run on Mac. And you run in a hospital, you don't want to necessarily get a Linux server physically in your hospital to run the software. You don't have to necessarily buy a physical device to run the software. You can actually provision this software in the cloud. That's what we refer to as platform as a service. You're going to be provisioning Linux platform as a service in the cloud without having to buy physical computer system that will run on Linux necessarily. We also have provision of cloud that helps the field of medicine called SaaS, which is the software as service. We have some softwares that can help enhance health inclinations. And we have many of those softwares that are being used by different hospitals to analyze data of patients, because there's no way when you talk about modern medicine without necessarily talking about the data of the patients and the data of the medical research, and of course the data of intellectual endeavor of the hospital. Data is key in modern medicine. So you can actually have a software that manages your data that you have to install on your system. For example, if you want to use data analysis, the prominent software that's got to do with you installing the software on your physical system is, let's say, Power BI by Microsoft, which many banks or which many hospitals use as a software to do data analysis. But cloud has also come to solve the problem of you buying a software and installing on your physical device necessarily. You can have a software as a service without having to necessarily install on your physical device. You can decide not to use the Power BI, because Power BI, you have to get the software, you have to physically get a physical computer device, then you now run it on those devices and you follow the installation protocols. Then when you want to launch the application, you find the icon on your desktop, your computer, you now launch. These are software that you physically install on your computer system. But you may not necessarily do that. You can have a software exist as software as a service, whereby you will just go to a web browser, www.so and so, then the software will exist on the web browser, then you can run your operation. And when you are done with the software, you can close your browser. You are not necessarily installing software on your system. You're not physically installing software on your system. Many of you guys have been using software as service without knowing necessarily. Example is Microsoft Office. Okay, the traditional Microsoft Office, you can get the CD, install it on your computer system, then you can launch your Microsoft Word format or your PowerPoint presentation or your Excel to do some certain data analysis. These softwares are physically installed on your computer, but Microsoft does also have these softwares as SaaS, software as service on the Azure cloud platform, whereby you can actually open a Word document online without necessarily installing Microsoft Word on your physical system. You can open the PowerPoint document online. So with the Microsoft Azure Office 365, it gives you SaaS, which is the software as a service for you to run. So you have begun to understand the power of cloud and how it does help in our daily productive endeavor. So you can additionally, patient support can be managed easily by cloud-based smart routing systems and customizable IVR. Medical imaging can be securely stored in the cloud platforms as they come equipped with the capacity to handle and learn from large data sets, which, when used in conjunction with big data analytics, can help with diagnosis, support, and speed of medical research and predictive healthcare. So, in the routine administration of a medical terrain, cloud computing plays a lot of role. And in terms of data interoperability, okay, and collaboration, collaborative healthcare is the new norm since the adoption of electronic health record. Cloud platforms work on the essence of interoperability and are capable of collecting, analyzing, and sharing data from various IoT devices. Pharmacies, medical insurance companies, hospitals, clinics, and healthcare providers, so that a more customer oriented approach can be implemented that also benefits all EHR stakeholders in eliminating errors and delays in exchange of vital information. Okay, when you talk about the data interoperability and collaboration, it also gives platform to what you call IoT. And I'm going to break it up by talking about Internet of Things, IoT, which is the generic way of integrating advanced technology in every of human endeavor. And in the field of medicine is often termed as IOMT. A typical example of that is if you have a freezer in your house and you want to have a power management whereby you want to monitor the usage of the power in your house when you are not at home necessarily. So you can decide to switch off your freezer remotely anywhere you are. And that is the power of Internet of Things. And Internet of Things has been driven more efficiently with advanced internet technology like a 5G and other advanced high bandwidth internet provisioning we have in the world today. You can decide to switch off the light in your room, away from your house. While in the office, you can decide to switch on your cooking gas and warm your food, and you monitor it. Once the temperature has gotten to a appreciable temperature, you can actually turn down all of these devices away from being active. So these are examples of how you can also leverage on Internet of Things, and these provisions have begun to be integrated in modern medicine today. And I've also talked about how these cloud computing technology can actually reduce costs, which of course I didn't authoritatively assert as reducing cost. But when you talk about how it can actually help you provision solutions without having to buy physical devices necessarily, then it helps in reducing costs. If you have a software, a medical software that has been pre-programmed to run on Mac operating system, and you have to deploy the software on 10 Mac operating system machines in your hospital. With the cloud, you don't have to buy 10 physical machines. You can provision these 10 machines, Mac operating system in the cloud. And if you go by how much it costs to actually get a Mac operating system driven laptop, today is pretty much expensive. But when you deploy this in the cloud, you can provision these infrastructures in the cloud without having to buy them physically. And that's when we're talking about the physical storage of data, like patient charts, invoices, medical reports, pharmacy prescription, accounting paperwork, all of these medical endeavors that we use in traditional or in our daily medical terrain can actually be deployed in the cloud. You realize that when you go to some hospitals these days, you still find some papers in there. We shouldn't still be using such in our terrain. The cloud has actually come to aid this laxity. If you have all of this data, being provisioned in the cloud, you can easily do your data analysis, and of course, you would have a smooth operation in terms of accountability of financial inclination of the hospital. You can have real-time data filtering of patients. You can have visibility in digital inclination of the paperwork as well. So this does help a lot. Hospitals, labs, and doctors don't need to invest in complex IT infrastructures anymore. If they migrate to cloud storage with pay-per-use and subscription models, they can simply focus on patient care instead of tech administration and operational costs. Because when you're running a software that monitors the heart of a patient physically in the hospital, you have a machine maybe that runs on an operating system, and this operating system, it could be, let's say, Windows Server 2012, and the software runs on the server that monitors the heart of the patient. And what the software does is it continuously stores the data, the breathing, the respiratory inclination of the patients for the doctors to use as the data for analyzing the health and the progress and the research for that patient. What happens if you at close of work and there's power outage suddenly, and the power, or there could be power hazard, and the computer packs up, or it burns, or there is an accident in the hospital that destroys the data? The hospital may have to begin to worry about how to recover the data that has been stored in the physical infrastructure over time. But with cloud, you don't have to physically have complex IT infrastructure in the hospitals anymore. You don't have to necessarily store patients' data physically on the Excel sheet and a physical computer system in the hospital anymore. If you are not using advanced data analyzing software, as tiny, as simple as Excel is, most hospitals still use Excel software on a physical device. The problem is not about using Excel software, but the problem is you are deploying your data analysis on Excel on a physical device, physical infrastructure that is prone to accident or damage, or being caught up with fire or technological attack that could actually annihilate the integrity of the data. You can actually provision a server in the cloud that will run an Excel, such that when you launch your system, your physical system, you are working on the cloud, in the cloud environment, so that if your system packs up, you are not your cloud data will still be intact, because you are only using your physical system to actually interface with the system in the cloud, which is quite better. Then we're going to be talking about telemedicine. Telemedicine is one of the most respected concepts of medicine in the world today, that has been driven by higher technology and cloud computing. Using cloud computing to provide virtual medicine has the potential to revolutionize the healthcare industry. Doctors and therapists can provide high quality, personalized care to patients virtually by using cloud-based apps and softwares. In terms of patient monitoring, cloud-based tools like biosensors, for example, this is a biosensors. Okay, so this is a cloud-based tool that, as the data or as data is being gotten from the patient, it's being migrated to the cloud in real time. So, which makes it quite distinctive. In terms of patient monitoring, cloud-based tools like biosensors in home care devices, wearables, etc., can provide continuity of care and promptly diagnose signals of distress and deterioration by remotely monitoring heart rate. For example, you have shoes that have when you wear some certain shoes, they have the devices to get the pulse rate of patients, the breathing rate of patients. Sometimes it could be a bangle you would wear on your palm, okay, that gets the pulse rate of your patient. So if you are a doctor in Nigeria, you could conveniently manage a patient in the UK because you have cloud computing as a tool connecting you and the patient. There is a physical device that monitors the heartbeat of the patient, and the physical device in real time stores the responses of the heartbeat to the cloud. From the cloud, the doctor has the privilege to monitor the data from the cloud. So when the patient begins to show some signs of distress, the monitoring tool in the cloud would alert the doctor to seek for emergency disposition to the patient. So these are modern ways of integrating modern technology and cloud computing to diagnosing patients. So this can also help in remotely monitoring heart rate, blood pressure, movement, and other bodily functions. Cloud computing enables video conferencing and multimedia medical consultation, diagnostic and treatment services, and as store and forward application, which is the ability to asynchronously transmit patients' medical data from one provider to another, for instance, from a lab technician to a specialist. So you can have a team monitoring patients remotely all over the world. You can have the lab technician in Turkey, you can have the patient in the US, you can have the doctor in Nigeria. The connectivity of the monitoring of the patient's medical inclination is being administered by cloud and modern technology, which connects all of these expertise together to bring forth medical advices in real time to ensure that the patient health is taken care of adequately. And we're going to be talking about how cloud is scalable. You may not necessarily spend a lot of money to begin your cloud adventure as a medical doctor. If you have 10 patients that you want to be able to manage their data in the cloud, you can provision a server that can manage 10 patients. It's not a must you provision a server that has a huge configuration when you will not be using it necessarily. If you have an hospital that has hundreds of patients and you want to deploy their data in the cloud, you can provision that. If you have 10 patients, so you can scale the type of provisioning you want to leverage on in the cloud, unlike a physical infrastructure where this may not be necessarily or conveniently easy to achieve. Then we have a privacy and data security, which is taken care of in the cloud. The area I'm going to be wrapping up in this section would be data analysis, which is a key part is defining the world of medicine, because artificial intelligence is the upcoming phase in the medical adventure that is going to eradicate direct interfacing with physical doctors. Before you meet a physical doctor, the world is transcending to you engaging with artificial intelligence first before you meet a physical doctor, which makes the world of medicine pretty much catenated in a way that gives accuracy and perfect consultancy in real time in multitude cases. Big data analysis. There's no way you would have artificial intelligence in medicine without having data collection first, because the basis of artificial intelligence is data, data science. If the data science is well founded on the premise of excellence, then artificial intelligence can actually come in to fix many lags in the medical world today. And I will implore many students of medicine or practitioners of medical line at the present time to leverage on data analysis that can help the field of medicine. I've talked about Power BI. If you want to actually start analyzing data, which helps in medical research. For example, you could decide to analyze how many cases of coronavirus do we have, in Nigeria. That is pretty easy, but you can go deeper by saying which state has the most coronavirus cases. You are doing data analysis. I can go deeper by saying, okay, which region of the state does have the coronavirus the most, and when you zoom the region, you can decide which sex, is it male or female, that have more coronavirus quickly, which gender, are we talking about, then the age bracket of those who have begun to be hit more with coronavirus. Then you can also go deeper by analyzing what time of the day do people get infected with coronavirus the more. And this data analysis will be based on the data provisioning that have been put in place. So before you can do deep data analysis, you have to take your data inputs professionally and in a way that would help you advanced analysis. So if you are taking the data of a patient that has been infected with coronavirus, for you to do this data analysis from where I've started, you have to get the states, you have to get the local government, you have to get the gender, you have to get the age, because if you are doing age featuring of those that have been infected, you can actually know which age bracket is being infected more. Then you ask the patient, what time did you start feeling these symptoms of coronavirus? Is it in the midnight or early in the morning or in the evening? If your data does show that people feel more coronavirus symptoms at night, then it can aid medical research to find out why is the body immune system so weak at that time. These are areas that the world of medicine is projecting into, and many doctors are actually making a lot of money using data analysis. Power BI, Microsoft Power BI is one of the tools. You can physically download the software on your system, go to Google, you can learn it free of charge. Okay. Or if you don't want to necessarily download the software on your system, you can also leverage on what I talked about earlier called software as service. You may not necessarily download the software in your system. You may leverage on the software as service. AWS does have something called AWS QuickSight. It's a software as service. You just go to www.QuickSight. I don't know the URL of the curve. If you Google it, so you go to the URL, you can do data visualization of what you have gotten. If you have documented all of your data, you have taken data of patients in a particular region, it is easy for you to visualize 4 data of people. Let's say you want to visualize data of 5 patients. It's very easy. You can tell what is the age bracket, what is the gender. What about if you have 5 million data for you to analyze? So you need a software to do the visualization for you, so you can see the physical visualization of the data. Can you all see my screen? I can see I have the pie chart there. I have Instagram. I have all of this data represented in different formats here. So these are areas that you could check out. AWS QuickSight, it's a fantastic solution as service that doctors can actually use to do data visualization. If you have an Excel sheet that has 2,000 patients' data, it will be quite difficult for you to visualize, brilliantly by analyzing the data. But if you use data visualization software, it's a pretty much success that would be achieved. Okay, so artificial intelligence, according to the Danny Greenfield of Harvard University, he says that the future of standard medical practice might be here sooner than anticipated, where patients could see a computer before seeing a doctor. I think I actually mentioned it not long. So, well, enough of the theoretical assertions. When I give presentations like this, I like to encourage people into having the veteran skill to be able to undo their challenges. We're talking about data analysis, we're talking about artificial intelligence. You may not necessarily have to leverage on softwares others have built to solve your problem. You could also write your software yourself, and that is where being a programmer comes in place. So you can learn Python as a programming language, which helps in data analysis. Okay, with Python, with dedication, 3-4 weeks, you can learn how to write Python. They can begin to use it for data analysis. And it's a big deal in the world of medicine today because many advanced hospitals all over the world are looking for doctors who are not just traditional doctors who have graduated from university, but doctors who have the skill of data analysis with basic programming language like Python. So it's pretty easy. If you go to Python, www.python.org. It's pretty easy to learn Python. Python has two popular frameworks. We have Django and Flask. Okay, so these two frameworks can be conveniently used to build web application in the field of data analysis and then, of course, in artificial intelligence as well. Then you could also want to transcend these IT delivery into mobile application. For example, I recently worked with a PhD student in South Africa who was researching about, the project was about, what was it? About reporting adverse effects of drugs in hospitals. So, people go to the hospitals, they get drugs, prescriptions for them, and when they go home and they use these drugs may work, but sometimes these drugs may have adverse effects. Okay, in our terrain in this part of the world, patients, once they are fine, maybe they're having headache, the headache is gone, but they're having itching in the body. That is an adverse effect of the drugs. They don't go back to the hospital to report necessarily, because if they do go back, it will help the doctors to study why some certain people react to these drugs, and it will help to study the world of medicine as far as that drug is concerned. But people don't necessarily give back to the hospitals or to the pharmacy or to the drug monitoring agency in the country to report the adverse effects of drugs. So these PhD students came up with an application in South Africa that allows patients to report adverse effects of drugs. So once you've taken a drug, it's working fine, but you reacted to it one way or the other, you report it, and the data goes into the research terrain of medical experts, and they begin to find out, okay, this drug works fine, but in some certain parts of this country, some people react to it, and they want to find out why is it that all over the country, just these people in this part of the country react to it. So they now look at what could be the cause. It could be the weather condition in that terrain. It could be some other things which will open new world of knowledge in the field of medicine. So this is a fantastic thing you could do without having to be a guru or a professional in software engineering. Okay, with you learning simple software applications from web application like HTML, like JavaScript, which you can use for the logic programming, and of course integrating with the database. Okay, so these are the things that you could also learn as a medical doctor. I have institutions, TechVarsity, that I train students on web programming and other ICT advanced courses. And I've seen medical doctors that have registered and they have actually done well over time. Okay, so I have also seen medical doctors who are gurus in software and engineering as well, because the best way to actually answer software problems in the field of medicine is when doctors begin to answer the questions themselves when they are also software engineers. So these are the skills that you could learn. HTML, CSS, JavaScript is a basic skill if you want to learn web programming. Okay, for the software I've just mentioned now, which is live software that enables patients to report adverse effects of drugs. It was a program with the web application tools, HTML, CSS, JavaScript, and the database, the Google Cloud Firebase database. Okay, so which allows the expert to go to the data and analyze why a particular drug is given adverse effect. So I'm going to reiterate this: the world of cloud computing and technology is evolving, and there's a lot the people in the medical profession could actually leverage on. But the best way a lot of questions can be answered technologically in the field of medicine is when those in the medical field also take the bold step to engage with the technology directly as the primary veteran engineer themselves, producing their softwares and developing their codes themselves and solving the problem of medicine using modern softwares themselves. Thank you for having me in this presentation. I do appreciate it, and I hope that this presentation is used as a working tools in our medical endeavor. Thank you so much.
Thank you, sir. Mr. Engineer Yusuf Aweda. I really appreciate the topic, and he really charged it and gave a practical demo and application of what had been said. So if probably or perhaps we have any question we want to ask him, this is the platform where we can ask. So I will give question space for only 5 participants to ask here. So if perhaps we have any other question to ask, then it will be after this webinar that is in the WhatsApp waiting group. So I don't know if any one of us has a question.
Hi. Hi.
Hello, who is that?
Hi. Can you hear me, please?
Yes, I can.
Okay. Actually, my question is based on the topic. Engineer Yusuf Jimaweda already explained everything in details, and I can say that's well. But I have a question on tech. I'm sorry, it's just that it's one-sided yet. So I just want to ask, and I'm sorry the question will be funny or something, or just let me ask. Can I go ahead, please?
Yes, you can. You can.
Oh, okay. Thank you very much. My question is, like, for example, we talked about the advantages and how we can even, like, there are some software that doesn't work on some systems or anything like that. Okay, for example, now, after all these advantages, and I feel like, okay, maybe I don't want to go to this thing for the advantages or the advantage. I just want to go, like, people make money there. Is that enough reason to just go into tech? Like, people make money there and I just want to make money. Is that enough reason? Like, do you feel like it's enough reason? I'm sorry the question is very funny and stupid, but then just ask me please. Because I have a friend. It's even me self. I don't like so like
So
is that
is
enough
money
reason?
enough reason to say you want to
Yes, to
do
dive into
technology,
tech.
Abi?
Thank you very
To
much.
dive
That's
into tech.
that's the question.
This is a very nice question, and I hope the content writer here is available listening to this particular question to actually update the people on that. So I don't know, Engineer Yusuf, I don't know if he's still on this platform to answer the question.
Okay, can you please reiterate the question of the questioner so that I can get?
He said he's having a mind of money. Like, is it enough? Is it sufficient to drive someone to learning tech? Like, if it is just the money you are interested in,
Is it sufficient to what?
to learn tech or to dive into tech with just the aim of earning. Like,
Like in the
Okay,
sense that
fine,
people
fine.
need money.
With the aim of earning, of course, you can decide to dive into tech to solve your financial problems. It's fine. It's fine. But of course, everything isn't about the monetary inclination. You have to also develop the passion to augment your intellectual endeavor in ICT. You have to have the passion, because if you just want to go into it with the aim of making money alone, the learning curve sometimes may be quite demanding. It may be quite exhausting and may be quite discouraging. But if you have the passion for it, it drives you further, not to give up, then of course you can get to the terrain of making money with it as well. So there's nothing bad about it.
okay, thank you so much, sir. So, in addition to that, I will actually say that, and well, it's a form of like a raw statement that if actually Pygad, like the company I founded, actually, if well, a company's aim is to earn money, but if we had actually thought of earning alone and not on having society impact, on making people like the better version they can, making tech and making a better tech community, then this kind of occasion won't actually be there. So what I'm trying to say is that we learning tech is far more than earning. There are many things really involved. You can learn tech for your passion to solve society problem. You can learn tech to earn money. Very naturally, you can do that. So there are many things you have to check on together. So I think regarding that, you should take your time, sit down, and have a book or better to write down the reason why you are doing tech. You probably you don't know, okay, earning is the only reason you had before. You surely find some things that can follow that will drive you along in learning that also if you do that. I think that has answered the question.
Yeah,
Hello.
it had. Thank you
So
very much.
okay, you're
Hello,
welcome,
good
sir.
afternoon.
I appreciate it.
Okay, sir. Welcome.
I have a question.
Okay, sir.
Hello.
I can hear you, sir. Aziz. Yes, sir.
Okay. Thank you for the session, Mr. Abdulwahab. So my question is, actually, I'm not a medical student, but I just have interest in this tech of a thing. So I heard you say in the last part that one can learn Python in about 3 to 4 weeks with dedication. So I want to say, maybe for a starter, somebody who isn't in the tech line before, who hasn't coded before, would you advise that person should start with Python, or which is the best route for one to go if one starts from scratch in order to become a software engineer? And the second question is, you also said you have a tech academy university that one can get into. How can I get more information on that? And purposely, how can I also get into your academy? Thank you.
Okay, thank you so much. On the question regarding the learning curve for Python, Python is the simplest programming language in the world. If you want to start with data analysis, solely for data analysis, you can learn Python directly, okay? But it also helps in when you want to go into machine learning and all of that. But if you want to have also the skill of building mobile applications, web applications, and all of that, so you need to learn your HTML, CSS, JavaScript, Node.js, React, and Angular. There are quite a lot of web frameworks you could use as well. So it's fine. You can decide to learn Python straight away as a newbie in programming. You don't need to know anything prior to it as a programmer. You go to python.org They have lots of stuff you could use, you could leverage on. Okay, so it's fine. It's fine for you to do that. You don't need to have with knowledge of programming. Then I thought about the school that I run, techvarsity.com.ng. Techvarsity is spelled TECVAR, not VER, VARSITY.com.ng. Okay, so you could read some of the courses we have there, then you could pick on any of them.
Okay, thank you so much, sir. So another question I have is that for someone to be employable, let's say, okay, someone just starting and had learned some of the skills and probably done maybe one or two practice work. How can such person can be employable and probably be able to freelance in the tech space?
Could you please summarize that? I didn't get that. What you're trying to say.
I said someone that had learned some tech skills and actually has done probably one or two projects, and
Okay.
probably yes, if such person wants to be employable or wants to freelance, what do you have about that? Is it someone
Okay. Yeah. You see, one has to understand what the world requires from that person. These days, the concept of having a CV is not enough. So you have mentioned one of the key things. You have a project you have worked on, so you have to have a GitHub account whereby you put your codes in there. Those are the things that your potential employers will want to check. Then of course your LinkedIn. Your LinkedIn is key stuff. So you have to be on LinkedIn, set your profile very well. Then you have to have content that you have written. Medium.com is an example of a place you could start uploading your content into, so that maybe when somebody Googles your name, it brings forth all of the articles you have written in the field of knowledge, of that technological inclination. Then you have your code stored in GitHub. You have projects that you have written, whereby on your LinkedIn they can be linked to those projects. So this is what employers look for now. Employers don't necessarily look for your CV again or anything. Recently, Google announced that for employing people, they won't be considering whether you have a degree or not anymore. So it has got to do with what you have got to put forth. So every tiny project you have done, every tiny article you have written, every tiny code you have written, you don't make it in your local terrain. You blow it open, you put them online for public visibility.
Okay.
So yeah, just for this last question, I need to go now. I have another meeting I need to attend to now, and I hope that I've been able to. So thank you so much for having me. I quite appreciate you. Thanks so much.
Hello.
So
Okay.
on a particular question someone actually asked some time ago. So the path to learning a program like Python, there is a particular PDF resource that is done in the past. So we will share it by the end of the class for free for everyone. We are going to share some resources for free for everyone, including our speakers' resources that we can also learn from. So those collection of resources, we can see some roadmaps. So those roadmaps you can learn, you can check the path to learning a program like Python, and can go to our YouTube, our Udemy to check free courses, if perhaps, or paid courses, so that we can use to learn. So I think that also can also assist. So if perhaps there's any other question.
Hello.
So
Hello, can you hear me?
Okay, I can.
Okay, yeah. So I wanted to add to the answering of I think what's his name is Aziz's question. Question. So learning Python is very quite easy. Like, it is very easy. So that 3 to 4 weeks that he's saying is not exaggerated. Do you understand? Because I can write at least 3 languages now, and I can tell you that Python is the simplest of all. Because it is generic. You can use it for anything, and it's English structured. You get? So Python is very, very easy. It's something that you can use for many things. So going into Python, you just need to learn the basics and things like that. So 3 to 4 weeks to learning Python is not something hard. Then I want to add my own question, in the sense that does PyGuard have any
program in maybe are they planning to bring out some of these things as projects, like this medical stuff as project as discussed today?
Yes. So there's a plan that at the end of this particular webinar, so interested people in actually forming a tech community, a medical tech community, will be added. Only interested people that are willing to actively involve in this. So it is not actually going to be maybe PIGA specific. It's going to be general people specific that are interested in going forth with this medical tech, and we are going to start the new things in being revolutionary about this quest. So that's one thing that we are going to inform every one of us at the end of the program. So whoever is interested in whoever
Okay, then my team and I will be very happy to help. And so thanks for the webinar and thanks for everything today.
We'll be a team in that together. So it's going to
No
be
problem. I get. Yeah. Thanks.
Okay. Do we have any other thing on those things? And one last thing is that probably
Hello, please. Hello, please. Mr. Wahab.
Okay.
Is that person that spoke now Alpha leader? Alpha leader?
Yes.
Okay. Yes. All right, thank you.
So I think I'll probably be handing the classes here. So if perhaps you have anything to say, we can inform or put the content on the waiting group for here on Telegram. So
Good evening,
we are active in this class, and
Good evening,
I hope that
please can I be heard? Good evening,
ma'am. I can hear you.
Please, I have a question for you. Please, can we get your private maybe contact for further questions, for further to know more about this stuff?
You mean? Do you mean the speaker or
you particularly, ma, not the speaker?
Okay.
At least
actually,
for
almost everybody.
like us.
I understand. Almost everybody in this program should have my number, because I take note of everybody's number. So probably I will write my contact after this webinar on this platform, so you can message me on WhatsApp. Do that.
All right. Thank you very much.
Okay, welcome. So thank you very much, everyone here. So I think today's webinar has ended. So we'll meet tomorrow where we'll actually talk on machine learning, where someone, a tutor, a medical student, and a person that has been an ambassador for different tech companies and is very vast in the tech world. He's a role model because he's a medical student, and again he's into AI and is now a tutor. So he learns directly from Workina AI. Perhaps some of us know it. It's very popular. So, and I hope we can start learn from him to keep things short. So, and probably I'll also hold a class tomorrow, and it will just be on how to actually learn, to combine learning all these skills with probably the work you're doing, with probably the school medicine, and I'll take some insights on some web design, on some tech skills. I'll just say some insights on that. So, and some necessary things I deem fit. So, and the other person I've said earlier. So, thank you for your time. And the next session will be question and answer session, the general question and answer session, and interactive session. So, if you have anything generally that you want to say, we can actually keep on messaging on the WhatsApp group. So I'll send both links on this platform if I have some are not there. So tonight, like starting from now to anytime tonight, will be the question answer group and general discussion group. So I'll anticipate to that. Thank you so much for your time. So I think this will be the end of this class. So thank you so much.
Hello. Good evening.
Who is that?
Good evening. Okay. We are allowed to ask questions on the general group, right?
Yes, you can ask. To be on it is a WhatsApp group so that we can ask.
Okay, sir. I'm on the group. Thank you, sir. I'll put my questions there since this
Yes.
today's
So
webinar.
there are 3 WhatsApp groups. So depending, no matter the WhatsApp group you have, just type the question. Anything. There's no restriction. Anything you feel you want to ask regarding tech and probably in relation to medical technology or general tech knowledge, or you can just ask. Try to make it interactive so that
Okay, sir.
we can actually learn from each other. So thank you for your time.
Thank you, sir.